These are your 3-6 notes on proportional and non-proportional relationships. We are going to look at characteristics of each. Some of them will have a story with them. We're going to look at graphs. We can look at tables of data. We can look at just a situation and determine whether the relationship between those variables is proportional or non-proportional. So they each have certain criteria that we look for. So in proportional relationships, the rate of change is constant. It will always be linear. So you can look at the slope and determine if it's a constant rate of change. The graph will pass through the origin every single time. In order to be proportional, 0, 0 has to be part of that data. The ratio of x to y coordinates will be constant, except when x is equal to 0, because 0, when you multiply by 0, it just turns into 0. And the equation will be formed y equals kx. So k is your constant. K is your constant. Notice if you plug in 0 for x, it'll just make it go away. So you want to look for a different constant rate. But notice nothing is being added or subtracted to this function. So if you have an equation, you can notice things are proportional right away because there's no plus or minus after the fact. It's just the x value multiplied by some number. For non-proportional, the rate of change might be constant. Just because it's linear doesn't mean that it's going to be proportional. So non-proportional relationships also occur. The graph will not pass through the origin. So that's sort of the difference. Is it a line going through the origin, or is it just a line crossing somewhere else, a different y-intercept? The ratio of x to y coordinates is not constant. It could be constant, but if it's not constant, then it's not proportional. If it is constant, you have to look further. So sometimes the rate of change will be constant, sometimes it won't. And then these are going to be the equations where you have a certain slope, and then you're going to add or subtract a certain amount. So these type of non-proportional equations will have a number here that we have to add or subtract to make it work. So let's just kind of go through some scenarios and determine whether they're proportional or non-proportional, and then we've got to come up with an equation. The equation should work for every single ordered pair in the actual data. So what I do is I use one ordered pair to come up with the equation, and then I check my equation using more than one ordered pair after that, 2 or 3 ordered pairs. So looking at this data, I'm going to see, does it go through 0, 0? Well, we can't tell that right now. I could graph it and see, but I don't really want to take that time. So we'll see if it was supposed to go through 0, 0 or not. So if I were to look at my change in my x values, I'm adding 1 each time, all the way through, so that's constant. Let's see if the same thing happens with my y values. They're increasing, and each of my y values is increasing by 3, by 3, by 3. So my rate of change is the change in y over the change in x. Yes, it's constant. So I can actually call it a slope of 3 over 1. Remember, it's your y value over your x value. Because we're talking about constant, we use the letter K for constant. You'll see that in science a lot. So really, M, K, they're interchangeable here, is 3. So since the rate of change is consistent and constant, that doesn't really tell me if it's proportional or not. It just tells me that it's linear. So I know it's linear, but looking back at our criteria, non-proportional can also be linear. The other thing I might look at is if I were to go to the previous problem, since I'm starting at 1, my previous x value would have been 0, because I would subtract 1 to work my way back through the data. So if I'm adding 3 each time going to the right, to get to the previous number, I would subtract 3. And when I subtract 3 from 3, I end up getting the ordered pair 0, 0. So that tells me that this is linear, but it also goes through the origin. Because when I reversed or backed up my slope and I went to the points previous, I subtracted 1 on top, I subtracted 3 on the bottom, and I ended up with 0, 0. So this is proportional. And to write the equation, I know my slope, it's my constant, is 3. Y is equal to 3x. So I'm going to check this with a couple of the ordered pairs. So if I plug in these ordered pairs, let's plug in 0, 0. Well, first of all, 0, 0 works. When x is 0, y is 0. I might just take this ordered pair 2, 6. And I'm going to check it. If I plug in 6 for the y value, does it equal 3 times 2? Yes, 6 equals 6. That's a true statement. If I use 4 and 12, does 4 times 3 equal 12? Yes. So you don't have to show the work for the check. I just plug in a couple points. It should work all the way down the table. So this is proportional, and my equation is y equals 3x. For the next problem, if you look at number 2 here, my x values are increasing by 1 each time. My y values are decreasing by 1 each time. And so that's constant. So I can say that my constant rate is -1 because it's a negative, my y value over my x value is -1 over 1. My change in y over my change in x, right? And so I do have a constant. I just don't know if it's going to be proportional or not. If I subtract and go back in time 1 from my x value, since those were increasing by 1, if I go to the previous point, it's 0. And my previous point before this was 4. So just looking at my previous point, 0, 4 is not the origin. 0 doesn't go through at 0. 0 goes through at 4. This is non-proportional. So I just used the table of values to my benefit here. I didn't have to show a ton of work there. It's non-proportional because it doesn't go through the origin. It is linear, so I can write the equation y equals -1x. Then I got to decide what I'm adding or what I'm subtracting to this. So how I do that is I pick any ordered pair. I might just use that first ordered pair here, 1, 3. When I plug in 1, y equals -1 times 1. Well, y equals -1, but it doesn't equal -1. If you look, I need that to equal 3. So when I plug it in and I multiply by the -1, I get -1. I need to make that equal 3. So what I need to do to my equation is I need to add 4 more to it to equal the 3. Now the ordered pair 1, 3 works. So I use the ordered pair 1, 3 to help me come up with my equation. So when I multiply my variable x by 1, in order to get my y value, I have to add 4 to it to get the right value. So my equation is y equals -1x plus 4. If we check it with another problem, let's try 3, 1. When I plug in 3 for x, -1 times 3 is -3. -3 plus 4 is 1. So it works. So you want to use one ordered pair to write the equation. And so you're just kind of guessing and checking for that 4 value. You're saying, okay, I got -1. How do I make -1 turn into the 3 that's in the table? Looking at number 3, I can tell right off the bat by looking at the picture that this is non-proportional. Even though it's linear, it doesn't go through the origin of 0, 0. So this is non-proportional. It is a line, though, so now I got to come up with the equation of that line. So I can look at some different ordered pairs. This is a nice ordered pair. That ordered pair is the ordered pair 2, 4. So maybe I'll use 2, 4 to write my equation. I also have this nice ordered pair here. This ordered pair is 4, 10. So when I look at this, my y values are increasing by 2, 4, 6. I went up 6. And then I went to the right to just 2 because my x values are counting by 1s. So I went to the right 2. And so if I look at my constant rate of change, I was increasing 6. For every 2 I went to the right, my constant rate of change is 3. I could write that down as ordered pairs. I could use the slope formula to figure out the same thing. Since I have the graph, I'm just going to count my slope. So I know the slope of this line is 3 units. But when I use the equation y equals 3x, I automatically know it's going to be wrong because that's the equation for a proportional relationship. So I know I'm going to have to add or subtract something. I'm going to use this nice 2, 4 point to help me figure it out. So when x is equal to 2, I get 6. I get y is equal to 6. but I need y to equal 4. So from 6, I got to subtract 2. So from my equation, I need to adjust by 2. I need to subtract 2. So this equation now works for the ordered pair 2, 4. When I plug in 2, 6 minus 2 is 4. It also works for the ordered pair 4, 10. 3 times 4 is 12, minus 2 is 10. So again, I used the 2, 4 ordered pair to write the equation, and then I checked my equation with the 4, 10 ordered pair. All right, just a few more. So here's energy. We're talking about hours and miles. Hours driving to the miles driven. So it says graph the data and determine any patterns about the relationship between the hours and miles. So since we're dealing with just the first quadrant in real life, make a sketch just of the first quadrant. My hours driving could affect the miles that I've driven. I'm going to scale my hours by 1. So 1 hour, 2 hours, 3, 4, and then I'm going to count my miles by 50s. So 50, 100, 150, 200. When I graph this, if I'm driving for 1 hour, I went 50 miles, 2 hours is 100 miles, 3 is 150, and 4 is 200. So right now I see a linear relationship here, and I would say that if I drove 0 hours, I would have gone 0 miles. So it makes sense that this would go through the origin here. So this is proportional. And it looks like as the hours increase by 1, the miles increase by 50. So I have a rate, or my constant rate of change is 50 miles per hour. Every hour, as my hours increase by 1, my miles increase by 50. To write an equation, I know I got my k value. Y is equal to 50x. I don't have to worry about adding or subtracting anything because it goes through the origin, so the proportionals are a little bit easier. Use the equation to predict the number of miles driven in 8 hours of driving. I'm going to replace my x value with 8. 8 times 50 is 400 miles. So I used the equation to predict outside of the information I had. My table didn't go to 8 hours, so I could have extended my graph, which would take a lot of time. I could extend my table, which would take a lot of time. But the way I did it is I just used my equation, and that's the quickest way to come up with the answer. Arithmetic sequences. Since arithmetic sequences graph lines, some of them will be proportional and others will be non-proportional. So we just have to see whether it would go through the 0, 0 or not. So they're telling us these are arithmetic sequences. If you notice here, my numbers are decreasing at a constant rate of 3. So my d value is 3. This is my a sub 1. I can write a function. A sub n is equal to a sub 1 times plus the quantity n minus 1 times, actually it's a negative 3 because they were going down by 3. And so I distribute. I plug this in. I have my 5 plus n minus 1 times negative 3. Distribute my negative 3 through. My nth term, 5 plus negative 3n plus 3. So I have this positive 3 and this positive 5. My equation, a sub n, is equivalent to negative 3n plus 8. Well, it looks a little bit different than y equals kx, but you could substitute the thing that we're equaling. The a sub n is my y value. My n value could be considered my x, which means negative 3 would be my constant rate of change. So because this looks like a formula where you have plus or minus afterward, this is going to be a non-proportional relationship here. So this would graph as a line. It would just not go through 0, 0. It would go through 0, 8. So a little bit different. I have the equation, and then based off of the equation, I decided whether it was proportional or not. For the next problem, I'm going to go ahead and look for my D value. Numbers are increasing by a constant rate of 4. So my D value is 4. Also, my A sub 1 is 4. A sub n is equal to A sub 1 plus n minus 1 times D. So my nth term is equal to my first term 4 plus n minus 1 times 4. Distribute the 4 through. A sub n is equal to 4 plus 4n minus 4. And what you notice is when you start at 4 and you count by 4s, A sub n is equal to 4n. The 4's canceled each other out. And that is the same thing as y equals 4x. This right here is a proportional relationship. So we worked with tables, we worked with graphs, and we worked with equations to decide whether they were proportional or non-proportional. So I'd like to see 2 characteristics of a proportional relationship. And then using that table of values, I want you to determine whether it is proportional or non-proportional. And then if it is, give me the equation. If it isn't, you'll be able to tell me why it's not. Good luck.